Welcome everyone to this live podcast on Twitch, where you can find the news from the research industry that how our researcher keep on researching on various topics and domains to keep our lifestyle better, of course. And this article posted on our website named postscientist.com. So, if you're willing to check it out, please check it out. Otherwise, listening to this podcast will be enough for you guys as it acts like an archive on the daily basis, providing you the information from the research industry. So, without wasting any further time, let's get started with the first topic of the day. Chinese incursions into India are increasing and a strategic plan study finds. So basically, it's a geopolitical study which is being provided to you. So let's see what we find in it. Chinese Chinese incursion across India west and central borders are not independent, random incidents that happen by mistake. Instead, these incursions are part of strategically planned, coordinated effort in order to gain permanent control of disputed border areas. A new study has found. Hmm. Led by Northwestern University, the Technical University of Delft in the Netherlands, and the Netherlands Defense Academy, the author assembled a new dataset compiling information about Chinese incursion into India from 2006 to 2020. Then they used game theory and statistical method to analyze the data. The researcher found that conflicts can be separated into two distinct sectors: West, Middle, the Aksai Chin region, and the East, the Arunachal Pradesh region. While the researcher learned that the number of incursions are generally increasing over time, they concluded that conflicts in the East and Middle sector are part of a coordinated expansionist strategy. By pinpointing the exact location lying at the root of the conflict, the researcher believed deterrents could be established in these specific areas to diffuse tension along the entire border. The study Rising Tension in the Himalayas, a geospatial analysis of Chinese border incursion into India, will be published on November 10th in the Journal PLOS 1. By studying the number of incursions that occurred in the west and middle sector over time, it becomes obvious statistically that these incursions are not random, said Northwestern VS Subramaniam, the study's senior author. The probability of randomness is very low, which suggests to us that it's a coordinated effort. When we looked at the eastern sector, however, there is a much weaker evidence for coordination. Settling border disputes in specific areas could be an important first step in a step by step resolution of the entire conflict. A world renowned expert in AI and security matters, Subramaniam and the Walter P. Murphy, professor of computer science at Northwestern McCormick School of Engineering and a Buffett faculty fellow at Northwestern Buffett Institute for Global Affairs. Incursion on the rise. The longest disputed border in the world, the Indochina boundary, has experienced recurring conflicts since 1962. Incursions tend to occur in two distinct regions: Aksai Chin, a region north of Nepal that is controlled by China that claimed by India, and Arunachal Pradesh, a region east of Bhutan that is controlled by India but claimed by China. So, I mean, if you wanted to know the history behind this, please let me know because we already been covered those types of topics. Yes. To construct their new dataset, the author compiled publicly Available information about border incursions that were well documented by international media. For the study, the team defined an incursion as any movement of Chinese troops across the border by foot or in vehicles into areas that are internationally accepted as India's territory. Of course, it's an India territory, man. I mean, okay. Then they plotted each location on a map, identifying 30 hotspots and where incursion happened most frequently. In the 15-year dataset, the researcher noted an average of 7.8 incursion per year. 7 to 8 incursion per year. The Indian government estimate, however, are much higher at 300 per year. Okay, okay. Sorry, 7.8, it's the right thing. And it's almost around the 300 per year. Okay, it's an average which he is talking about. Although the Indian government publicizes these numbers, we don't have the details behind them, Subramanian said. They might be counting a series of temporarily approximated events as several different incursions, whereas we count all them all as part of the same one incursion. But when we plotted our data and the data on a graph, the curves still have the same shape. Both curves show that incursion and increasing, but not steadily. They rise and fall while still trending upward, keeping the pot boiling. All the hotspots occur throughout Aksai Chin and Arunachal Pradesh. The researcher game theory analysis indicates that only the incursion and Aksai Chin are a part of coordinated effort. Building on insight from game theory, the researcher predicts that China is trying to establish permanent control over the Aksai Chin by allocating more troops for a larger period, for a longer period of time than India. Okay, okay, fine, man, great. China grabs a little bit of territory and then a little bit more until India accepts then it's China territory, Subramanian said. There is a saying, keep the pot boiling, but don't let it boil over. China takes small pieces of land but keeps it under the threshold of where India would counterattack, but over time it becomes a bigger piece of land. Okay, fine, great. The finding that China is most interested in acquiring exciting supremacy supports common knowledge. Okay. Knowing there was more incursions in the western sector is not a surprise, he said. Exciting is strategic area that China wants to develop, so it's very critical to them. It's a vital passageway between China and the Chinese autonomous region of Tibet and Xinjiang. Okay, okay. Finding solution. In a previous paper published by Nature, Humanities and Social Science Communications in 2021, Subramanian and his collaborators studied when incursions are most likely to occur. They found that China attacks when it feels most vulnerable. We found an uptick in incursion when China is experiencing economic stress such as low consumer confidence. Subramanian said, we also see upticks when India gets closer to the United States. Now that Subramania and his team understand when and where these incursions occurred, they next plan to explore how to address them. The study author believe military intervention should be a less resort. Instead, they suggest bilateral negotiations, developing early warning system to predict when incursion might occur, or bolstering Indian economy ball steering Indian economy in order to challenge China economic dominance. Okay. China reverse economy result in increased aggression around the world. Subramanian said no one wants a war. Just not just in terms of lives, but in terms of economic ripple effects. It would be an economic tsunami. Okay. So I mean, it's been a various and vast topic, and many historical aspects are being going to be discussed well. to understand this strategically fine topic and important topic for the Indian government and the Chinese government as well. So, I mean, I have more, uh, no more talk about this because it's of course it's the international matter and geopolitics. So, never mind. We are most likely to get into the research thing, not into the geopolitics thing. So, yeah. Moving on to his next topic. Scientists identify neurons that restored walking after paralysis. Okay. In a multi year research program coordinated by the two directors of Neuro Restore, George Cortin, a neuroscience professor at EPFL, and Jocelyn Bloch, a neurosurgeon at Lansing University Hospital, Chu, a patient who had been paralyzed by spinal cord injury and who underwent target e- epidural electrical stimulation of the area that controls leg movement, were able to regain some more some motor function. In the next study by a neuro-restore scientist appearing today in Nature, not only was the efficiency of this therapy demonstrated in 9 patients, but the improved motor function was shown to last in patients after the neuro rehabilitation process was completed and when the electrical stimulation was turned off. This suggests that the nerve fiber used for walking uh, had reorganized. The scientists believe it was crucial to understand exactly how this neuronal reorganization occurs in order to develop more effective treatments and improve the lives of as many patients as possible. VX2 neurons recognized to restore walking. Okay. To arrive at this understanding, the research team first studied the underlying mechanism in mice. This revealed a surprising property in a family of neurons expressing the VH2 gene. While these neurons aren't necessary for walking in healthy mice, they were essential for the recovery of motor function after spinal cord injury. This discovery was the culmination of several phases of fundamental research. For the first time, the scientists were able to visualize spinal cord activity of a patient while walking. This led to an unexpected finding. During the spinal cord stimulation process, neuronal activity actually decreased during walking. The scientists hypothesized that this was because the neuronal activity was selectively directed towards recovering motor function. Okay. To test their hypothesis, the research team developed advanced molecular technology. We established the first 3D molecular cartography of the spinal cord, says Cotton. Our model let us observe the recovery process with enhanced granularity at the neuron level. Thanks to the highly precise model, the scientists found that spinal cord stimulation activity activates VH2 neurons and that the neurons become increasingly important as the reorganization process unfolds. Versatile spinal implant. Stephen Lacord, a fellow EPFL professor, helped the research team validate their findings with the epidural implants developed in their lab. Lacord adapted the implants by adding light emitting diodes that enabled the system to not just stimulate the spinal cord but also to deactivate the VH2 neurons alone through an optogenetic process. When the system was used on mice with a spinal cord injury, the mice stopped walking immediately as a result of the deactivated neurons, but there was no effect on healthy mice. This implies that VH2 neurons are both necessary and sufficient for spinal cord stimulation therapies to be effective and led to neural reorganization. It's essential for neuroscientists to be able to understand the specific role that each neuronal subpopulation plays in a complex activity like walking, says Bloch. Our new study in which 9 clinical trial patients were able to recover some degrees of motor function thanks to our implants is giving us valuable insight into the reorganization process for spinal cord neurons. Jordan's cured focus on regenerative therapies within neurostores adds this paves the way to more targeted treatment for paralyzed patients. We can now aim to manipulate these neurons to regenerate the spinal cord. Hmm. So, I mean, this is the finding given by our scientists on the neurons walking, restore walking after paralysis. So, I mean, great for the people uh, who are paralyzed due to some conditions. So, I mean, great for doctors, great for patients. So, yeah. Moving on to our next topic, biofuel combined with advanced engine design shows promise for energy and cost savings. Hmm. Biofuel is closer to becoming a cost competitive, climate friendly solution for slashing carbon emission in cars and trucks, according to two new studies. The US Department of Energy (DOE) Argonne National Laboratory has collaborated with the DOE National Renewable Energy Laboratory and Rail Pacific Northwest National Laboratory (PNNL) and Idaho National Laboratory (INL) on the research. Result shows that biofuel combined with advanced engine design can reduce greenhouse gas emissions by roughly 60% while improving fuel efficiency or reducing tailpipe emissions. Argonis Energy System analyst Paola Thino Benavides Enrail process engineer Andrew W. Bartling and PNNL engineer Stephen Phillips were, were lead analysts for the two study published in ACS Sustainable Chemistry and Engineering. Biofuel has significant advantage over petroleum gasoline, but the engines themselves are also critical to energy efficiency. Designing low carbon fuels and engines to work together can maximize energy use and vehicle performance. We are the intersection of new innovation, both engines and biofuel, say Troy Hawkins, Argonis Group Manager, Fuels and Products Group, and author on both ACS Sustainable Chemistry and Engineering Studies. Our goal was to develop new biofuels blended with conventional fuels to improve engine performance. This means a gasoline powered car or truck could go further on the same amount of fuel, or a diesel vehicle could meet more stringent emission standards. In both studies, Argonia scientists worked with other national labs to identify promising fuel for different engine types. Researchers considered cost, environmental impact, and potential for expanding to commercial markets. Argonis is a part of co-optimization of fuels and engine co-optima initiative jointly led by DOE Office of Energy Efficiency and Renewable Energy Bioenergy Technology Office and Vehicle Technology Office. Co-optima consortium consists of 9 national laboratories and over 20 university and industrial partners. The COSTRUM studies how simultaneously innovation in fuel and engine can boost fuel economy and vehicle performance while reducing emissions. Scientists and experts at every DOE laboratory played an important role in each phase of the research. Hawkins said this research is a really good example of how laboratories can work together to help the DOE accomplish its mission. Finding biofuel pathways. Co-optimal research builds on the goal to identify and understand bioblend stocks or biofuel. Biofuel is produced from biogas, organic materials including plants, agricultural waste, and wet waste. Biofuel can be blended with the conventional fuel to reduce emission and improve fuel and engine performance. Collaborating with co-optimal fuel experts, researchers used a screening process to develop a list of biofuels. Further research, Benavide said. Argonne scientists developed the list of biofuel working with experts including PNL technical team manager and co-optimal leadership team member Daniel Gaspard, NREL senior scientist Gina Fidoni, and Rail Senior Research Fellow Robert McCormick, and Anthony George, Senior Manager at DOE Sandia National Laboratory SNL. We worked with other experts to use specific criteria to narrow many biofuel candidates down to a short list for our research. This list was developed based on the required properties and the engine combustion mode, Benowite said. Converting biomass to biofuel is a complex process involving variable in feedstock, conversion technologies, and fuel types. It is especially challenging finding biofuel pathways that also meet economic, technology, and energy goals. My study was co-first authored by Benavides. The team accessed 12 biofuel production pathways for optimizing multi-mode internal combustion engines. Multi-mode engines can deliver greater efficiency and cost saving by using different methods of ignition, combustion, and or fuel preparation depending on driving demands. Researchers used renewable biomass feedstock found in forestry, bioproducts such as wood waste, and agriculture bioproducts such as corn straw wood. They used conversion technology including either fermentation, catalysis under high heat and pressure, or a combination of both. We found that not only can 7 biofuel be produced cost competitively, but that these 7 are varied in terms of feedstock use and conversion technology, Bartling said. This means that biorefineries can be more flexible in choosing where and how to build their facilities. Andrel and PNL researchers did a techno-economic assessment of the biofuel production pathways, analyzing cost and technology performance. Our findings showed that many of the biofuels are competitive with the current cost of petroleum fuel, Phillips said. Researchers also analyzed environmental impact, a life cycle analysis of the pathway using argon and GREET, greenhouse gases regulated emission energy using technologies. Model showed impressive result. 10 biofuel have the potential to reduce GHG emissions by 60% compared to petroleum gasoline. The list includes alcohol, furan mixtures, and olefins. Biofuel promising for diesel engines. The second study was co-first authored by Bartling researcher analyzed 25 pathways for producing biofuel optimized to improve combustion for mixing control, compression, ignition engines. These are a type of diesel engine mainly used for freight transportation. To develop biofuel production pathway, researchers use feedstock ranging from plant materials such as wood chips or corn straw wood to oil from soybean cuphe to wet waste and recycled grease. They use conversion technology including fermentation, gasification, and hydrothermal liquefaction. The diverse set of biomass resources available in the US has great potential to replace a portion of fuels and chemicals that now come from petroleum, said Damon Hartley, INL's Operation Research and Analysis Group lead. However, one of the largest barriers in the wide variability in quality in the raw materials. This can have a large impact on how the material performs in conversion. Moving on towards next topic. As with the first study, most of the technology performed well. Most of the biofuel were cost competitive with current gas prices. In terms of environmental impact, GHG emission were reduced more than 60% in 12 of the 25 pathways according to the GREET life cycle analysis. We evaluated the life cycle GHG emissions for each mixing control, compression, ignition, engine pathway. This included not only the tailpipe emissions but also upstream emission resulting from biomass cultivation, feedstock, transportation, biofuel production, and biofuel distribution, Hawkins said, creating a biofuel playbook. Researchers did not tend to produce a definitive list of biofuel benefits said. Instead, the studies offered a guide for stakeholders on selecting biofuel pathways that best meet their needs. We provide research and industry guidance on assessing biofuels based on a number of complex variables. Benavide said, the life cycle and techno-economic analysis is important in guiding stakeholders as early as possible. We can't tell stakeholders what choices to make, but these tools can point them in the right direction from the beginning. While many of the biofuel pathways could potentially be cost competitive, it is too soon to lock in prices in a constantly fluctuating gas market. The challenge of providing cost competitive prices in the long term, Hawking said. While these biofuel production pathways target cars and diesel trucks, organic researchers are also studying the potential for using this pathway in hard electrify sectors like aviation and maritime industries. The goal is to bring biofuel to market across a range of industry as quickly as possible. Department of Energy and Resources is constantly working on sustainable solution for decarbonizing the transportation sector. Biofuel is a big piece of that. Of course, man. Honkin said we will continue to expand on co-optima important work along with Argonia, ORNL, NREL, PNL, INL, and SNL other USDOE national labs in the co-optima initiative are Los Alamos, Lawrence Berkeley, and Lawrence Livermore National Laboratories. So I mean, it's a great thing. Of course, many of the developed and developing countries moving their energy resource to a more sustainable way, because of course it's going to affect on our mother earth. So it's a necessity to take appropriate actions to do have an impact and sustain this environment. Moving on to our next topic, study demonstrate tailored icing superconductivity in intercalated bulk niobium niobium diselenide diselenide. Okay, when 2D layered materials are made thinner, that is at the atomic scale, their properties can dramatically change, sometimes resulting in the emergence of entirely new features and in the loss of others. While new of emerging properties can be very advantageous for the development of new technology, retaining some of the material original properties is often equally important. Researchers at Tsinghua University, the Chinese Academy of Sciences, and the Frontier Science Center for Quantum Information have recently been able to realize tailored icing superconductivity in a sample of intercalated bulk niobium diselenide NBSE2, a characteristic of bulk NBSE2 that is typically comprised in atomically thin layers. The method they used, outlined in a paper published in Nature Physics, could pave the way towards the fabrication of 2D thin layered superconducting materials. Atomically thin 2D material exhibit interesting properties that are often distinct from their bulk materials, which consist of hundreds and thousands of layers. Shun Yunzo, one of the researchers who carried out this study, told physics.org. However, the atomically thin film flakes are difficult to fabricate, and the emerging new properties are sometimes achieved by sacrificing some other important properties. Zhou and his colleagues have been trying to identify experimental methods to achieve more novel properties comparable to atomically thin samples without losing any vital material properties for some years now. In their recent study, they specifically evaluated the effectiveness of electrochemical intercalation, a valuable strategy for tuning the electronic properties of layered solid materials. The bulk material is immersed in the ionic liquid, which consists of cations and anions. Zhou explained such ionic liquids have been widely used for injecting electrons into few layer samples, while while the ions remain in the liquid. We have found out that by applying a larger negative voltage, the large size organic cations can be driven into the van der Waals gap, the empty space between the active layers NBSE2 layers, in this case, forming hybrid materials. In that experiment, Zion and his colleagues found that intercalation is an effective strategy by controlling both the dimensionality and carrier concentration of their NBSE2 layered sample. Using this strategy, they were able to attain a tailored icing superconductivity that exceed both that observed in bulk NBSE2 crystals and monolayer NBSE2 samples, but in an intercalated bulk NBSE2 sample. Essentially, intercalation strategies consist in the immersion of a bulk material in an ionic liquid and the subsequent application of electrical voltage. This process prompts an increase in the spacing between a bulk layered material active layers, reducing intercalation between them. Although the intercalated NBSE2 material still consists of many layers, its properties behave quite similarly to those of monolayer NBSE2 samples. Zhao said specifically, the intercalated material superconductivity can survive under a large in-plane magnetic field, but the superconducting transition temperature is higher than monolayer NBSE2. In addition, the cations can transfer charges to the active layers and act as protecting layers, making the hybrid material stable in the air. While Zhao and his colleagues specifically used their intercalation based strategy to broaden the properties of a layered 2D NBSE2 sample, the exact same strategy could also be applied to a wide range of layered material to achieve properties comparable to those of monolayered version of these material or even better. So far, this method has enabled tailored icing superconductivity in NVSE2 enhanced superconducting veil semimetal MOTE2 and semiconducting to superconducting transition in SnSe2. Our intercalation method is quite generic and can be readily extended to a large variety of layered materials and a large selection of ionic liquids with different cations Zhao added. Therefore, our work provides an important pathway for creating hybrid materials with tunable functionalities, possibly exceeding the bulk crystal and monolayer samples. Beside superconductor, we would like to apply this strategy to many other layered materials to obtain more intriguing properties. We expect that thanks to intercalation intriguing property exceeding both bulk crystals and monolayer sample will soon be enabled in a growing number of layered materials. Hmm. Moving on to our next topic. Study investigate the extent to which e-scooters and e-bikes displace cars using real-world data. Okay, let's see. Drastically reducing greenhouse gas emission is of utmost importance to mitigate climate change and its detrimental effects. To work towards this goal, most automotive transport companies are investing in hybrid and electric vehicles as well as other emission free means of transportation. In recent years, mobility technologies such as e-scooters and e-bikes have become increasingly popular in many countries including the United States and the Netherlands, Germany and Austria. This technology could be an affordable and environmentally friendly alternative to motor vehicle for both residents and tourists, allowing them to circumvent traffic and easily navigate urban environments. While in some US states and other countries worldwide, these vehicles are no longer allowed on the road due to the rise in accidents. Some experts believe that they could drastically reduce greenhouse gas emission by displacing that is substituting existing cars. So far, this has primarily been a hypothesis due to lack of evidence supporting its validity. Researchers at Georgia Institute of Technology have recently carried out a study investigating the impact of e-scooters and e-bikes on car displacement in an urban environment. Their finding, published in a paper in Nature Energy, suggests that micro-mobility technologies do tend to substitute cars and reduce traffic, consequently reducing greenhouse gas emissions. There is an unsettled debate on whether the use of e-scooters and e-bike reduce emissions and provide sustainability benefits by displacing cars for last mile travel. Omar Isaac Incencio, one of the researchers who carried out the study, told Tech Explore. Many advocates claim that e-scooters and e-bike can reduce emission and therefore should be encouraged, while other studies based mainly on surveys or simulated datasets claim that scooters mainly displace trips that would otherwise be made by walking or public transit and therefore do not meaningfully reduce congestion or provide sustainable benefits. Of course, man, I mean, if we are going to analyze the news, the findings, and the studies, so it's more likely on the daily purpose and the city based purpose on the walking distance sides. But for the larger area, it's going to be useful or like powerful cars only, of course, man. In 2019, the city of Atlanta banned e-scooter from the road between 9 p.m. and 4 a.m. after a series of fatal accidents, complaints about their presence on sidewalks. Okay, this ban offered Encensio and his colleagues the opportunity to test what happens when micromobility technologies are no longer available in a real world natural setting. Of course, man. Let's see what we find in it. We leverage high resolution data from Uber movement to study the effects of the e-scooter ban on travel time for recurring evening trip pre and post policy intervention. And since you explained, through our analysis, we settle a standing debate and provide definitive evidence that e-scooter and e-bike displace car for last mile travel in the urban center. Based on this finding, sites will have weigh trade-off between micromobility restrictions designed to promote public safety and unintended congestion and its associated emission worth up to $536 million in the value of the lost time nationally. Interestingly, Encensio and his colleagues observed that after the 2019 e-scooter ban, the average commute across the city of Atlanta increased by 9 to 11% in normal traffic conditions, and by 37% at the time of large events such as a soccer game at the Mercedes-Benz Stadium. Based on the result they collected, the researchers estimate that micro-mobility bans could have a significant economic and environmental impact, costing the US government several millions of dollars, while also increased greenhouse gas emissions. Overall, the finding presented in the researcher paper confirmed that e-scooter and e-bikes displace existing motor vehicles, reducing greenhouse emission and traffic congestion in urban areas in the future. They could guide the decision of policymakers related to micro mobility solutions, but as encouraging the development of alternative and less restrictive strategies aimed at preventing accidents and fat- fatalities. Fatalities. Okay. But my lab is studying how behavioral decision can impact policy design choices for transport electrification. And since you added, our next study will focus on understanding the relationship between short run and long run behavioral changes that can promote sustainability benefits, particularly from a broader set of users who may not necessarily be environmental conscious. E-scooter mobility provides a promising path forward to help users engage in pro-environmental behavior. Okay, okay. Great man, great. Moving on towards next topic. Rats bombing to the beat in window. Rats bombing to the beat in video demonstrate innate beat synchronization in animal for the first time. Hmm. Accurately moving to a musical beat was thought to be skill innately unique to humans. However, new research now shows that rats also have this ability. The optimal tempo for nodding along was found to depend on the time constant in the brain, the speed at which our brains can respond to something, which is similar across all species. This means that the ability of our auditory and motor system to interact and move to music may be more widespread among species than previously thought. This new discovery offers not only further insight into the animal mind but also into the origin of our music, of our own music and dance. Can you move to the beat or do you have two left feet? Apparently, how well we can time our movement to music depends somewhat on our innate genetic ability, and the skill was previously thought to be uniquely human trait. While animals also react to hearing noise or might make rhythmic sounds or be trained to respond to music, this isn't the same as the complex neural or motor process that work together to enable us to naturally recognize the beat in a song, respond to it, or even predict it. This is referred to as a beat synchronicity. Of only relatively recently research studies and videos have shown that some animals seem to share our urge to move to the groove. A new paper by a team at the University of Tokyo provides evidence that rats are one of them. Rats displays in it that is without any training or prior exposure to music, beat synchronization, most distinctly within 120 to 140 uh, beat per minute, to which humans also exhibit the clearest beat synchronization, explained Associate Professor Hirokazu Takahashi from the Graduate School of Information Science and Technology. The auditory cortex, the region of our brain that processes sound, was also tuned to 120 to 140 bpm, which we were able to explain using our mathematical model of brain adaptation. But why play music to rats in the first place? Music exerts a strong appeal to the brain and has profound effects on emotion and cognition. To utilize music effectively, we need to reveal the neural mechanism underlying this empirical fact, said Takahashi. I'm also a specialist of electrophysiology, which is concerned with electrical activity in the brain, and have been studying the auditory cortex of rats for many years. The team had two alternative hypotheses. The first was that the optimal music tempo for beat synchronicity would be determined by the time constant of the body. This is different between species and much faster for small animals compared to humans. Think of how quickly a rat can scuttle. The sound was that the optimal tempo would instead be determined by the times constant of the brain, which is surprisingly similar across species. After conducting our research with 20 human participants and 10 rats, our results suggest that the optimal tempo for beat synchronization depends on the time constant in the brain, said Takahashi. This demonstrates that the animal brain can be useful in elucidating the perspectual mechanism of music. The rats were fitted with wireless miniature accelerometers who could measure the slightest head movements. Human participants also wore accelerometers on headphones. They were played 1 minute excerpts from Mozart's sonata for two pianos in D major K448 at four different tempos: 75%, 100%, 200%, 400% of the original speed. The original tempo is 132 BPM, and results showed that the Riot's beat synchronicity was clearest within the 120 to 140 beats per minute range. The team also found that both rats and humans jogged their head to the beat in a similar rhythm, and that the level of head jerking decreased the more that the music was sped up. To the best of our knowledge, this is the first report on innate beat synchronization in animals that was not achieved through training or musical exposure, said Takahashi. We also hypothesized that short term adaptation in the brain was involved in beat tuning in the auditory cortex. We were able to explain this by fitting our neural activity data to mathematical model of the adaptation. Furthermore, our adaptation model showed that in response to random click sequences, the highest beat prediction performs occurred when the mean interstimulus interval, the time between the end of one stimulus and the start of another, was around 200 milliseconds, 1000 of a second. This matched the statistics of internote intervals in classical music, suggesting that the adaptation property in the brain underlies the perception and creation of music, as well as being a fascinating insight into the animal mind and the development of our own beat synchronicity. The researchers also see it as an insight into the creation of music itself. Next, I would like to reveal how other musical properties such as melody and harmony relate to the dynamics of the brain. I am also interested in how, why, and what mechanism of the brain create human culture of field such as fine art, music, science, and technology and religion, said Takahashi. I believe that this question is the key to understand how the brain works and develop the next generation AI, artificial intelligence. Also, as an engineer, I am interested in the use of music for a happy life. Spontaneous beat synchronization rates, neural dynamics, and motor entertainment is published in Science Advances. Hmm. Great, great. I mean, it's providing you the finding, providing you the research on the on the red, which is being experimented by the scientist itself. So, great. Moving on to our next topic. Watch a virus in the moments right before it attacks. Okay. When Courtney C.J. Johnson pulls footage from the PhD dissertation, it's like she's watching an attempted break in on a home security camera. The intruder cases it targets without setting a foot inside, looking for a looking for a point of entry, but this intruder is not your typical burglar. It's a virus filmed over 2.5 minutes by pinpointing its location 1000 times a second. The footage shows a tiny virus particle, thousands of times smaller than a grain of sand, as it lurches and bobs among tightly packed human intestinal cells. For a fleeting moment, the virus makes contact with the cell and skims along its surface but doesn't stick before bounding off again. If this was an actual home break in, Johnson says this would be the part of the burglar has not broke the window yet. Johnson is a part of Duke University team by assistant chemistry professor Kevin Wechsler, together with Wechsler postdoctoral associate Jack Axel and colleagues. They have come up with a way to capture real-time 3D footage of viruses as they approach their cellular targets. The research is published today in the journal Nature Methods. We inhale, ingest, and take in millions of viruses every day. Most of them are harmless, but some of them, such as the virus that cause the flu or COVID 19, can make us sick. Infections start when a virus binds to and enters a cell, where it hijacks the cellular machinery to make copies of itself. But before it can break in, a virus has to reach the cell first, Johnson said. The often means getting through the protective layer of cells and mucus that line the airways and the gut, one of the body's first lines of defense against infections. The researcher wanted to understand how viruses breach these frontline defenses. How do viruses navigate these complex barriers? Welcher said. But these critical early moments before injection begins have been long have long been difficult, if not impossible, to watch with existing microscopy methods, he added. Part of the reason is that viruses move 2 to 3 orders of magnitude faster in the unconfined space outside the cell compared with its crowded interior. To make things even trickier, from an imaging perspective, viruses are hundreds of times smaller than the cells they infect. That's why this is such a hard problem study, Johnson said. Under the microscope, it's like you're trying to take a picture of a person standing in front of a skyscraper. You can't get the whole skyscraper and see the detail of the person in front of it with one picture. So the team developed a new method called 3D tracking and imaging microscopy 3D trim, which essentially combined two microscopes in one. The first microscope locks on to the fast moving virus, sweeping a laser around the virus tens of thousands of times per second to calculate and update its position as the virus bounces and tumbles around in the soupy exterior of the cell. The microscope stays continuously adjusts to keep it in focus. While the first microscope tracked the virus, the second microscope takes 3D images of the surrounding cells. The combined effect, Welcher said, is akin to navigating with Google Maps. It not only also shows your current location as you drive, it also shows the terrain, landmarks, and the overall lay of the land, but in 3D. Sometimes when I present this work, people ask, is this a video game or a simulation? Said Johnson, now a postdoctoral associate at the Howard Hughes Medical Institute Geneva Research Campus. No, this is something that came from a real microscope. With their method, the researcher can't just say watch a healthy person breathe in virus particles from an infected person cough or sneeze. For one, they have to attach a special fluorescent label to a virus because they can track it. What the microscope follows is the movement of the glowing spot, and currently they can only track a virus for a few moments at a time before it does dim. The biggest challenge of our for us now is to produce brighter viruses, Excel said. But Wechsler said he hopes the technique will make it possible to follow viruses in action beyond the covered slip and in more realistic tissue, like environments where infection first take hold. This is the real promise of this method, Wechsler said. We think that's something we have the possibility to do now. Okay, okay. Great, 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 great. Moving on to our next topic. Chemists create an artificial photosynthesis system 10 times more efficient than existing systems. For the past 2 centuries, humans have relied on fossil fuel for concentrated energy. Of course, hundreds of millions of years of photosynthesis packed into a convenient, energy-dense substance, but that supply is finite, and fossil fuel consumption has tremendous negative impact on Earth climate. The biggest challenge many people don't realize is that even nature has no solution for the amount of energy we use, said University of Chicago chemist Ben Lin. Not even photosynthesis is that good. He said, we will have to do better than nature, and that's scary. One possible option scientists are exploring is artificial photosynthesis, reworking a plant system to make our own kinds of fuel. However, the chemical equipment in a single leaf is incredibly complex and not so easy to turn out to own purposes. A natural catalyst study for 6 chemists at the University of Chicago shows an innovative new system for artificial photosynthesis that is more productive than previous artificial system by an order of magnitude. Unlike regular photosynthesis, which produces carbohydrates from carbon dioxide and water, artificial photosynthesis could produce ethanol, methane, and other fuels. Through it has a long way to go before it can become a way for you to fuel your car every day. The methods give scientists a new direction to explore and may be useful in the shorter term for production of other chemicals. This is a huge improvement on existing system, but just as importantly, we were able to lay out a very clear understanding of how this artificial system works at the molecular level, which has not been accomplished before, said Lin, who is the James Frank Professor of Chemistry at the University of Chicago and senior author of the study. We will need something else. Without natural photosynthesis, we would not be here. It made the oxygen we breathe on Earth and it's make the food we eat, said Lane, but it will never efficient enough to supply fuel for us to drive cars, so we will need something else. The trouble is that photosynthesis is built to create carbohydrates, which are great for fueling us, but not our cars, which need much more concentrated energy. So, energy looking to create alternates to fossil fuel have to re-engineer the process to create more energy-dense fuels, such as ethanol or methane. In nature, photosynthesis is performed by several very complex assemblies of proteins and pigments. They take in water and carbon dioxide, break the molecules apart, and rearrange the atoms to make carbohydrates, a long string of hydrogen, oxygen, carbon compounds. Scientists, however, need to rework the reaction to instead produce a different arrangement with just hydrogen surrounding a juicy carbon core, CH4, also known as methane. This re-engineering is much trickier than it sounds. People have been tinkering with it for decades, trying to get closer to the efficiency of nature. Lin and his lab team thought that they might try adding something that artificial photosynthesis system to date haven't included amino acid. The team started with a type of a material called a metal organic framework or MAOF, a class of compound made up of metal ions held together by an organic linking molecules. Then they designed the MOF as a single layer in order to provide the maximum surface area for chemical reaction and submerge everything in a solution that included a cobalt compound to ferry electrons around. Finally, they added amino acid to the MOF and experimented to find out which worked best. They were able to make improvement to both halves of the reaction, the process that breaks apart water and the one that adds electrons and protons to carbon dioxide. In both cases, the amino acid helped the reaction go more efficiently, even with the significantly improved performance. However, artificial photosynthesis has a long way to go before it can produce enough fuel to relevant for widespread use. Where we are now, it would need to scale up by many order of magnitude to make a sufficient amount of methane for our consumption, Lin said. The breakthrough could also be applied widely to other chemical reactions. You need to make a lot of fuel for it to have an impact, but much smaller quantities of some molecules, such as the starting materials to make pharmaceutical drugs and nylons, among others, could be very useful. So many of these fundamental processes are the same, said Lim. If you develop good chemistries, they can be plugged into many systems. So these are the study, these are the findings given by our scientists on these artificial uh, drugs. So great man, great thing. At last, I just wanna say, you guys keep researching, stay curious, stay healthy.